Open circuit scuba is probably what you'll be most familiar with. In an open circuit system, a tank containing high pressure air is connected to a regulator. The regulator lowers the air pressure to the ambient pressure so you can breathe easily. The air you breathe out is simply released into the environment. The first scuba systems were actually semi-closed circuit rebreathers. In a rebreather, the air you exhale is circulated back through a device that scrubs, removes the carbon dioxide, and adds more oxygen so that the air can be reused. In a closed circuit rebreather, none of the exhaled air is released into the environment. In a semi-closed circuit rebreather, a small amount of air is released into the environment. Rebreathers carry their own risks and require special training, but they are gaining in popularity again. They are often used by technical divers and by underwater photographers and videographers. Modern open circuit regulators have two stages, the first stage and the second stage. You attach the regulator first stage to the tank and it lowers the pressure of the air to an intermediate pressure, which is about 9 bar above the ambient pressure. The first stage has two chambers, a high pressure chamber and an intermediate pressure chamber. The high pressure chamber is connected to the tank and supplies air to the intermediate pressure chamber. The intermediate pressure chamber has small holes so that it is open to the ambient water pressure. The water can get into the first stage. The intermediate pressure chamber also has a diaphragm or a piston that closes the valve to the high pressure chamber when a pressure of around 9 bar above ambient pressure is reached. When you inhale, the air pressure in the intermediate pressure chamber drops to below the ambient pressure. This causes the water pressure to push in and move the diaphragm or the piston, which opens the valve to allow the air to flow in from the high pressure chamber. The air flows for as long as the diver inhales, because the pressure in the intermediate pressure chamber stays lower than the ambient pressure. When the diver stops inhaling, the pressure in the intermediate pressure chamber rises until it again reaches the intermediate pressure. Now the valve closes until the diver inhales again. With a simple first stage, the water actually enters the intermediate pressure chamber. This means that the water comes into direct contact with the moving parts of the regulator. Many first stages have an environmental seal. This is a small amount of silicone, liquid or alcohol that seals the intermediate pressure chamber. Rather than water actually entering the intermediate pressure chamber, the water pressure pushes on the seal. And this means that no water comes into contact with the moving parts of the regulator. This is important in cold water or in dirty water. In cold water, the water in contact with the moving parts can cause them to freeze up, and in dirty water, it can contaminate the inside of the regulator.
First stages can be balanced or unbalanced. In a simple, unbalanced first stage, the air pressure from your tank assists the opening of the valves in the first stage. And that means as the tank pressure gets lower, it becomes harder to breathe. Also, if you require more air on a deep dive or you have a body breathing from your tank, it also becomes harder to breathe. In a balanced first stage, the spring system works independent of the pressure in your tank. So the regulator always breathes just as easily. Unbalanced regulators are fine for shallow recreational diving, and they're easy to maintain too. Most rental regulators will be unbalanced. Balanced regulators are more comfortable, but more expensive and harder to maintain. So they will often be used by serious divers and dive professionals. Let's have a look at the second stage. You hold the second stage in your mouth and it reduces the air pressure to the ambient pressure, so you can breathe easily. A second stage is basically a plastic cup that's open at the bottom, so the pressure inside is equal to the pressure outside. A second stage is a demand valve. It only supplies air when you breathe in. When you breathe in, the pressure in the second stage drops below ambient pressure. This means that the surrounding water pressure pushes on a diaphragm outside that opens the inlet valve. This is more or less the same as what happens when you push the purge button. When you breathe out, the pressure gets higher than ambient pressure. This opens the valve that lets the air out, and at the same time it closes the valve that lets the air in. There are two types of valves in second stages. Some second stages use downstream valves and some upstream valves. Downstream valves open with the flow of air, and upstream valves open against the flow of air. Downstream valves are simpler, and if they break, the valve will be stuck open. This means that air will start free-flowing. You can still breathe from a free-flowing regulator, so we call this a fail-safe regulator. A fail-safe design doesn't mean it will never fail. It simply means that you can still breathe from it when it fails. More expensive second stages may have systems with an upstream valve. These systems have a pilot valve that opens the main valve. And this means they breathe easier, but they are not fail-safe and they're harder to maintain. Most second stages have a venturi system. This is simply a piece of plastic that disturbs the airflow around the diaphragm, and it causes the air to swirl, making it easier to suck up the diaphragm. On the surface, the venturi valve should be set to minus. On a dive, it should be set to plus. If you go diving with nitrox with more than 40% oxygen, there are special requirements for your equipment. Your regulators must be oxygen clean, and O-rings, lubricants, must be suited for high oxygen. This is because oxygen is aggressive stuff, and it corrodes things very easily or sets them even on fire.